I'm not able to join, but want to check it out later. So, just because I'm like Johnny No Technology today, are you guys able to see the POD?
Yeah.
Fantastic. Go ahead and do that first one. I'll give you guys about 3 or 4 minutes here. So maybe at like 10:35, we'll go over this one. Okay, so what we're trying to establish is using either AA, SAS, or SSS, are the triangles similar? Well, clearly in this first one, the only thing I can test is SSS because all we know are the sides, right? So we got to make sure. So what I'm going to do is just grab the biggest side in the biggest triangle. And obviously that'll correspond with the biggest side in the smaller triangle. So 7.2 over 6, I believe, is 1.2. And let's do the same thing with the next biggest side in the big triangle, which is 6, divided by the medium side in the smaller triangle, which is 4. No, thank you. I'm really on it today. Which is 5, and divide those, and those are 1.2. And then the last set, 4.8 divided by 4, I believe is also 1.2. Because we can see that the scale factor there is 1.2 consistently for every set of sides, then the two triangles are similar, and they're similar by SSS similarity. So let's see if we can come up with the right similarity statement. Triangle, let's see, A to B goes across the biggest side, and then B to C is the shortest side. So QSR, I believe, is the right order there. Questions on that first one? Okay. And And speak up at any time. If you guys have questions on stuff, fire away, please. So let's see with this next one. The only thing we can test is SAS, right? And I see that because we've got vertical angles in the middle here, I've got a pair of angles that are equal, the sides around them, I know, so let's see. And this is a little bit tricky. The 8 actually corresponds with 6 in the smaller triangle, and that's going to equal, I believe, 4/3 or 1.3 repeating. So we're going to do the same with 9 over 6.75, and I believe that one also is 1.3 repeating. Therefore, triangle DEF is similar to triangle. Now, because D corresponds with L, I would say that it's similar to triangle LMF. Questions there? Give me a verbal okay if we're ready to go to the next question. You guys ready?
I have a question.
Yes.
Does it matter which one you put over and which one you put under?
No, as long as you're being consistent. Like if I compared 9 to 6 and then 8 to 6.75, that would matter. But as long as I'm going in the right order and you're still getting a consistent number there, then you'll still be okay.
Okay, thank you.
Good question, Christina. Okay, you guys ready for some more here?
Yeah.
All right. So for X, I'll give you guys about 6 minutes here. So at, let's say 10:45, we'll go over this one. Hey, so not that it impacted you guys, but I think if I remade my diagram so that it's a little bit more drawn to scale here. So hopefully you're able to set up your proportion to solve for x in that first one a little easier now. So about one more minute. Okay. So, a few ways to think of the first one, but remember when we've got kind of three right triangles that are all embedded in one another, another way to say it is if you take the altitude of the biggest right triangle, it creates three similar triangles. So if I just look at this red triangle on the left and the blue triangle on the right, that's all we're going to need to set up the right proportion here. So let's take the one on the left. If I say 8 over x, in other words, short leg over long leg, equals the same thing with the blue triangle, short leg over long leg. Okay? Now, could you have had other variations of this proportion? Sure. 8 over x equals x over 12, or you could have the x and 12 on the left. But either way, when I cross multiply, we should all be getting x squared equals 96. Take the square root. And no, it's not like 9 point something. It's always good for us to try to simplify that. So I do my thing over here. I'm like, dang, okay. 2, 4, root 6. Depending on how the problem is stated, if if you left your answer as a decimal in that one, I'd probably be okay. There's some times later in the test where we'll specify, okay? But the key here is setting up that proportion that I just circled and then solving for x. So hey, let's check out this next one. I see in the bottom here that of this whole bottom side, that's 60, part of it's 20. So this other part has to be 40. And now a lot of you might have the mental math to say, all right, well, x is just going to be 80. If not, that's okay. If I look at this top portion, I see I've got two sections of that bigger side. In other words, I'm free to say that x over 40 equals 40 over 20. So you can cross multiply and divide. You can just multiply both sides by 40. But if I do it this way, I'll still get that x is 8. Fire away. What questions do you have on those two? Nothing? All right. We're going to do one more, and it's going to have a little bit of stuff from SOHCAHTOA, law of sines and law of cosines. Hopefully you've got those rules or formulas in your notes. Here is the last set of problems here. And we'll go over this one at about, let's say, 55 or 56. Okay, please keep working on these. I'm gonna start putting our answers up just so we'll have time to look at them. Okay, so there's the first couple. Because I've got right triangles in those first two, and I know enough information, I can do sine, cosine, or tangent. So in that first one, because I've got the opposite side, I've got theta, I need to find the adjacent. Tangent is opposite over adjacent, so I use tan. It's going to be 10 over tan 51. So I'm guessing you got something a little bit less than 10, maybe 8 and change, 9 and change. What'd you guys get for that first one?
8.1.
8.1. Nice. Heck yeah, okay. In this next one, I forgot to actually give you guys a measurement. Hold on. We'll get back to B because you can't do B without knowing another number. So, why don't you guys work on B real quickly. Okay, so like I had set up, for B, I can start with sine of theta equals 17 over 22. I'm using sine because 17 is the opposite and 22 is the hypotenuse. And sine is opposite over hypotenuse. So theta is the inverse sine, 17 over 22. We use that inverse feature when we're solving for angles. And shout out what you got. I'll tell you if I got the same thing.
$50.6.
About 58.6. That's what I got.
Yeah.
Awesome. Okay, next one. Kind of looks like a right triangle, but it isn't quite. So we have to use either law of sines or law of cosines for C. I've got enough information to use law of cosines. So I say Z over sine of 42 equals 17 over sine of 50. So Z is 17 sine 42 over sine of 50. And I got about 14.8. And then for our last one here, we got to use law of cosines. And we get r by taking the square root of that whole thing. Running into our next class, I apologize. And I got about 8.6.
Yeah.
So that's it. Sorry to run a little bit over with the technical difficulties earlier. If you guys have any questions, shoot me an email. Have a wonderful Wednesday. I'll see some of you tomorrow and Friday.
Thank you.
Thank you.
Thank
You're
you.
welcome.
Thank you.
Thank you so much.
You guys are awesome.